Imagine a world completely empty of any foundational chemistry. No periodic table hanging on a classroom wall, no understanding of molecules, and absolutely no scientific formulas telling us how the stuff around us is actually made. Welcome to this explainer, where we're going to explore exactly how humanity stepped out of the mystical guesswork of the 8th century and into the dawn of true empirical science. Okay, let's dive right into this. What if you literally had no idea what things were made of? Seriously, look around the room you're in right now. The glass in your windows, the synthetic dyes in your clothes, the refined metals in your phone. Imagine looking at all of that and having absolutely zero clue how it came to be. Back then, without quantitative measurements or standard procedures, replicating anything reliably was just impossible. There were no labs, no controlled formulas. Every physical transformation was basically this unrepeatable, chaotic mystery. But then, everything shifted. Enter a guy named Jabir ibn Hayyan. Widely known today as the father of chemistry, over 1,200 years ago, he stepped into a laboratory and became, well, the ultimate disruptor of his era. He didn't just accept the natural world as some impossible puzzle you couldn't solve. Instead, he began actively experimenting with minerals, metals, and chemicals in a way that totally rejected the superstitions of the time. You have to realize, before Jabir, the whole understanding of matter was dominated by alchemy and magic. It was an era defined by, honestly, mysterious guesswork, mystical beliefs, and terribly recorded observations. People genuinely thought changing matter was a magical or spiritual act. But Jabir? He introduced systematic observation. He brought in this radical, rigorous idea of carefully testing, heating, and dissolving substances. He essentially ripped the study of matter away from mystical guesswork and forged it into a hard physical science. He was basically forging the scientific method in real time. By carefully observing reactions, accurately recording his exact measurements, and systematically repeating his experiments, he built a framework for undeniable truth rather than mystical theory. He realized early on if an experiment couldn't be quantified and repeated, well, it wasn't science. This structured, methodical approach, which relied heavily on precise weights and proportions, is the exact thing that let him identify and isolate materials that were completely unknown up to that point. And the results of that rigorous method? Absolute game changers. Jabir discovered incredibly powerful acids, nitric acid, hydrochloric acid, early forms of sulfuric acid, and all sorts of chemical salts. Now, it's absolutely crucial to understand that isolating these substances took incredibly high, sustained heat, something nobody could control before. These weren't just curious bubbling liquids, they were groundbreaking new tools of chemical transformation that finally gave humanity the leverage to unlock the hidden secrets of matter. The jump in capability here was just awe-inspiring. Up until Jabir, humanity mostly relied on relatively inactive liquids. Water, basic oils, things that didn't do much on their own. But these new acids were like scientific superpowers. They could literally eat right through metals. They could completely change the fundamental colors of materials. They produced these dramatic, violent, yet highly controlled chemical reactions. For the very first time in history, scientists actually had the physical agents they needed to actively control and transform matter at will. Which brings us to a massive practical question. What would modern pharmaceutical companies and chemical factories do today without these acids and salts? Seriously, take a second to think about it. Every single modern lab, every factory churning out life-saving medications or advanced synthetic materials relies directly on the foundational substances first isolated and studied inside Jabir's laboratory over 1,000 years ago. If he hadn't done this work, our modern industrial world, no way it could exist. What Jabir didn't stop at just identifying these substances. He put them straight to work. The practical applications of his new compounds were totally vast. We're talking revolutionizing medicine, the rigorous purification of metals, creating vibrant dyes, and even advanced glass manufacturing. Jabir wasn't just sitting back passively observing nature. He was a creator. He was actively mixing minerals under precise temperatures and conditions to engineer entirely new materials that had completely new, highly beneficial properties. So, the crucial point is this core philosophy. Matter can be changed and manipulated through scientific processes. Before Jabir, a material was just what it was, a static piece of the world. But through his brilliant mathematical approach, a substance became just a starting point. By proving that elements combine in specific proportions and that materials could be deliberately transformed into new things through controlled reactions, he established the beating heart of chemistry. It's the exact same concepts driving all chemical engineering today. Now, you might be wondering, how exactly did he achieve such precise, controlled manipulation? Well, it was through vital technological innovation, specifically his absolute mastery of the alembic. This was a vastly improved piece of lab equipment used to gently heat materials and collect their highly purified vapors through distillation. The sheer genius of the alembic was that it allowed for the controlled cooling of those vapors. That specific mechanism was the missing technological link needed to achieve unprecedented purity when separating complex substances. Previously, scientists had to deal with impure, deeply messy mixtures that were poorly understood, mostly because everything was just jumbled together. But thanks to the alembic's distillation process, they could finally extract separated components with stunning accuracy, which allowed for rigorous, isolated study. This distillation technique was so brilliant, so incredibly effective, that the idea spread like wildfire throughout the Islamic world and eventually into Europe, and it remains a crucial industrial process right up to this very day. The scale of his global legacy is just monumental. Think about it. Over 1,200 years ago, Jabir is meticulously recording hundreds of substances, reactions, and procedures. Then, centuries later, his invaluable written works are translated into Latin, crossing vast borders and entirely different cultures. Fast forward right into the modern era, and European scientists are using these exact translated works as the essential foundations to build modern chemistry. The scientific disruption that started in one single 8th century lab eventually educated an entire continent. Ultimately, Jabir's works sparked a monumental shift, literally transforming alchemy into concrete chemistry. His unwavering commitment to evidence-based conclusions, his insistence on structured experimentation, and his meticulous record-keeping, they didn't just add to science, they permanently changed the course of it. He took a world operating on magical assumptions and forged it into a discipline of concrete, repeatable truths governed by actual physical laws. So, I leave you with this final thought. The next time you see a life-saving medicine being manufactured or high-tech metals being purified for the very devices you rely on every single day, who do you have to thank? It all traces back to a brilliantly curious scientist standing beside a furnace 12 centuries ago, methodically mixing, weighing, observing, and searching for undeniable knowledge. He gave us the power to finally understand what our world is made of and the absolute tools to change it forever.